Hello everyone, I welcome you once again. I welcome you all on the YouTube channel of TEQIP classes. So this is all about me, and we were already discussing the subject which is a machining and the machine tool operations. But after completing two chapter, because in the very first lecture I discussed there are three chapters. So after completing two lectures, I dropped this, but again I have started this one. First two chapters that is related. First chapter which was related uh, with the basics of the metal cutting, okay, basics of the machining. So that we discussed, and 13 lectures we have covered in that, okay. And next is that second chapter was based on the conventional machining operations. Means there are different types of the machine tools like lathe, milling, drilling, shaper, grinding. So that we discussed in 7 chapters. Okay, so total 20 lectures we have covered in these two portions. Now, today onwards, we are starting the third chapter, which is based on the non-conventional machining operations. Okay, sometimes we are also calling it as unconventional machining. Means in some of the books it is unconventional, in some of it is non-conventional. So before discussing about this non-conventional part, I just want to brief you, because some of you has asked that like there are some of the operations, like if we talks about the drilling, reaming, broaching, gear manufacturing. Okay, in this super finishing and micro finishing operations like honing, lapping. Okay, so this we have not discussed, but many PSUs, or if you will talk about the state public service commissions, or in gate examinations also, the problem objective questions has been asked from these operations as well. So it that till now I have not covered, it doesn't mean that I will not cover, because I have not covered, because these are like just operations. Okay, there is, if there is no separate machine is required for these operations. Okay, means if we are talking about the boring or the reaming operations, then for these operations, even though broaching also, for these operations a tool is required. Means a tool has been changed, and accordingly the operation has been changed. So that's the thing, we have given a separate name to these operations, but we are mounting this like if we are talking about the reaming or the boring operations, then both can be performed on a drilling machine or in the lathe machine. Okay, so there is no much difference. The machines that we have discussed till now, that will be the same in future when we will discuss these portions. Okay, so the operation is different. So if it is the operation, then what we have to discuss, we just have to discuss about the tool and the operation. Means it's a definition. Okay, so that's it. Rest machining part will be same. So that's why it is a very small topic. So as I said in the last few videos as well, okay, that I will take these individual topics in when we will take the miscellaneous part. So once let me complete this unconventional machining, then we will take that part. Okay, and if you feel that apart from these, the name that I have took in front of you, if you feel that any other process which you want to learn, okay, that also we will discuss in this one. Okay, so let's start with this unconventional machining operation. So in the unconventional machining, why we are calling it as unconventional, because of there are many reasons, but basic are like, in conventional machining, the workpiece and the tool in direct contact, and there will be a removal of the material. Also there is a mechanical mechanism we are using to remove of the material. Okay, but in non-conventional machining, there is no direct contact. There will be tool in the workpiece, but there is no direct contact. Okay, the second thing is, like, why we are using this non-conventional part, because like if in conventional machining we are using the tool and the workpiece. Okay, like as you will increase the strength of the workpiece, in conventional part I'm talking about, if you will increase the strength of the workpiece, then no doubt you need the harder strength of the tool. Okay, because then only that will remove the material, otherwise it will reciprocate, sorry, vice versa otherwise. So we if we are increasing the strength of the workpiece, then we have to make the tool accordingly. Okay, for an example, if we are using the gear manufacturing on the gear manufacturing, if we are manufacturing the gears, then we need the shape of the gear, okay, as a tool. So means replica of that we want. So how we will make this replica? If we are using enough strength of the workpiece, then how we will make make the replica of this gear over this workpiece. Okay, before that there is no availability of the tool if we are using the hardest material in the conventional part. So what we can do is we can use the non-conventional machining operations. Means there is means we can make the tool not only by making the direct contact but indirect contact. Indirect contact means we are calling it as a non-conventional machining. Means like there are different operations are available through which we can remove the material. Okay, now if we are talking about the chemical machining or the electrochemical machining, in which we are using the electrical energy plus chemical energy, means chemicals or the electrical energy we are using, and through which we are removing the material. If we are talking about the electric discharge machining, then we are using this discharge through the electricity. Okay, then only we are removing the material. So we can say that these non-conventional machining operations, in which there is no direct contact of the tool and the workpiece, but there will be a removal of the material. Also we can say this is basically a multidisciplinary operations, because this is not complete mechanical. Okay, electrical energy is also there, mechanical chemical energy is also there. Okay, so this is the thing, that's why we are calling it as a non-conventional. Okay, in मैं जितना easy way में समझा सकता था, ठीक है. Now, so let's start the lecture number 21, which is based on the milling machine and the chemical machine and the machining and the chemical milling. Okay, so once again, I welcome you all on the Let's Crack the Gate along with the TEQIP faculties. Okay, so let's start. So first is chemical machining is a process in which the piece is dissolved in a chemical solution. Okay, so the material is removed after dissolving inside the container. So this is the container. Okay, and inside this container we are filling the chemical solution. So chemical solution is nothing but here we are calling it as a etchant. Okay, etchant. Now second is the we are using the electric motor. Okay, and the electric motor is connected with the steerer, means shaft, and shaft is connected with the steerer, so it is rotating. It is we are keeping this steerer inside the fluid, means chemical solution, so that it is continuously rotating, and that will not allowing to means stationary the fluid. मतलब फ्लूइड को हमें यहाँ पे स्टेशनरी फ्लूइड नहीं चाहिए. वी वांट दैट देयर शुड बी अ कंटिन्यूअस सर्कुलेशन एंड दिस शुड बी यूनिफॉर्म. ओके, सो फॉर दैट ओनली वी आर यूजिंग दिस स्टीयर, सो दैट इज मेंटेनिंग दैट वन. Also there is another assembly we are using, that a heating element. Okay, so this heating element we are using because of the reason that is, if we have the soft material or the harder material. Okay, and if it can means from both, if we are using a single chemical solution, means etchant, and it can remove the material from both the workpiece. First workpiece which is made up of the soft material, second workpiece which is made up of the hardest material. So if a single etchant can be used to remove the material from both the workpiece, then there can be a possibility that if you will use this etchant at the room temperature, at that time only this will remove the material room temperature, then only that will remove the material from the soft material. Okay, but when you will increase the temperature, then only that will remove the material from the harder one. Okay, so a single etchant is there, but if we need to increase the temperature, so for that only we are using this facility. If you do not want, just remove it, because that is nothing but the separate attachment only. Okay, so we can remove this part. Now this is a workpiece, this one is the workpiece. Okay, and outside this is a mask. Okay, so the operation through which we are applying the mask, we call it as a masking. Okay, and apart from that the area is there, that is not masked. Okay, that is come in contact with the chemical solution. Simple mask is like now the pandemic situation is going on, so it's easy to understand the masking, that how to apply the mask over the face. Okay, so this is the mask, okay, and we are fixing it over. Okay, why we are fixing it over a particular space? Because from that area we do not have to remove the material. Means it means that जिस पे mask नहीं लगा है, जिस पे mask covered नहीं है, from that area only we want to remove the material. So how we will remove the material? We have to dip it inside the container where the chemical solution is filled. Okay, and now this surface here, there is no mask, so this surface will come in contact with this agent, and we'll keep it for some time. Okay, and there is some etching rate is there, rate of etching is there, so like we can say that 0.025 mm that will remove in 5 minutes. Okay, so through which we can get the value of that in 1 minute how much amount of the material is removed when there will be a throughout this agent will come in contact with the workpiece. So that idea we can get it from there. Okay, so this is basically the simple process. Okay, now the second is okay, the part of workpiece from which material is removed is not required. Material is not required. Cover the mask means this portion. We do, if we do not want to remove the material from the workpiece, then we are applying the mask over it, and the process we are calling it as a masking. Okay. Therefore, material from the unmasked portion of the workpiece is removed due to the chemical reaction. So from here, the material is removed due to the chemical reaction. Okay. Now, like there are 5 to 6 or 4 to 5 steps are there. If you will follow different books, then in one of the books it is 4 to 5, in another books it's 6 to 7. So I'm just combining all these steps. Okay, I think 4 to 5 steps, and then only like it's not fixed. Okay, it depends. So what are the steps that we can follow in the chemical machining operation? Is first is the residual stresses. Residual stresses is very high. Okay, sorry, let's residual stresses to be relieved in order to prevent wrapping from the mechanical part, machining part. What is the meaning of that? Is residual stresses is basically the internal stresses. Okay, means internal stresses of the workpiece material. Now, as I said in the beginning, that we are using this non-conventional machining operations for the materials which has very high strength, which we cannot remove its workpiece or remove its material from the conventional machining. So if the strength is very high, it means the internal resistance is already very high. So first of all, if we are applying, if we are using these materials in the chemical operations, then first of all what we have to do, we have to relieve this residual stresses little bit. Okay, so for that there are different types of the operations, like heat treatment operation we can perform. Okay, so through which first of all we relieve these stresses, and then we are keeping mask on that, and then we are dipping it inside the chemical solution. So that will basically prevent the wrapping option. Okay, wrapping means, here the wrapping means once we, because hardest material is like once the material is start removing from the workpiece part, then it can initiate a crack. Okay, so once if the crack is initiated, then there is a material, because if it is a crack, then there will be a formation of the flaw. Okay, if there is a flaw, if there is a formation of the flaw, then okay, then the material, the liquid chemical solution, there may be a chances that that can move inside, so that will basically propagate, and that will basically break the complete workpiece. So that, for that only we have to keep in mind this one. Okay, next is the surface degrease or the clean. The same option, because to ensure the good adhesion of the masking material and the uniform material removal, because like for an example, if like this is the workpiece surface, this is the workpiece surface, if it is here we are fixing the mask. Okay, if it is not cleaned properly or some grease is there, and we are keeping the masking on that itself, means what will happen, because of the greasing, greasing is basically used to uh, reduce the friction. Okay, so what will happen, there is a, we want that there is a strong bonding between this mask and this workpiece material. Okay, so if there will be a grease is there, then this will lose the friction and lose the bonding between these workpiece and the mask. So there may be a chances that chemical solution can be filled inside this inside these two surfaces, and that will again causes the same thing, damage the workpiece. Okay, So that will basically unfulfill, because of that unfulfill the operations. Okay, means machining, chemical machining operation will be unfulfilled. So that's why we are using this one. Okay. Now, second is the masking. Third one is the masking. The material like tapes, cello tapes I'm talking about, and the paints, okay, elastomers and plastics are applied. So these are the category basically. For the steel, there is a different types of the masking material are available. For aluminum, there are the different types of the material is available. Okay, so these are fixed. Okay, because otherwise it will create a problem. Okay, without greasing itself, it will not wrap up properly on the workpiece surface, so that will create the same things. Okay, the main disadvantage of this chemical operation is that अगर मान लीजिए कहीं पे लीकेज रह गया आपका small amounts में भी, then chemical will go inside that and that will create the problem. Okay, so that's why we have to keep in mind. Second one is the last one is the exposed surface. So this is these are etched with the elements. Okay, we are using the NaCl and HCl for the steel and the aluminum. Okay, so these are the etchants that we are using, and the exposed surface, which is over that there is no masking is applied, so that will come in contact with these chemical and that will remove the material. Okay, it is I already told you that temperature control and steering is important to obtain a uniform depth of the material removed. Okay, because if it will continuously rotate, like if we are using the heating element, then if this will not if the chemical solution will not flow, then what will happen, the temperature will be rising only which is the liquid material which is near to it. Okay, the rest it will be there at different temperature. So for the keeping this temperature constant, we have to keep rotated one. So that's why we are also using this stirrer. Okay, next is the mask and the etchants. So mask is the material through which we are wrapping, and the etching etchants, which is removing the material from the workpiece. So for the mask, what property should be required, that it should has a chemical resistance. Means whatever the chemical solution we are using, means as I said, that hardest material we are using, and from that we are removing the material. So if we are removing the material, then means there is a chemical bonding is there, means chemical reaction is takes place, and because of that only the material is removed. So that chemical reaction should not means that chemical reaction should be avoided between the mask and the chemical agent. Okay, otherwise if it will react with that, then that will create the problem. It will start removing material from the mask itself. Okay, so that will create a trouble. So that we have to keep in mind, and for that thicker maskants can resist the erosive action for longer period. So if we have to prevent this removal of the material from the mask by the chemical action, then we have to use the thick mask. Okay, thick maskants. The quantity of parts, like as I said that we are just using the chemical solution in the container only, we are filling that. Okay, and apart from like if we are if our the part size, the thing, the means output what we require, if it is very less, then the size of that is very less, then what we can do is we can keep the number of after keeping the masking, after the masking we can keep the number of components into that vessel or the into the container. Okay, so that the same operation can be performed on a number of quantity. Okay, so the large quantity can be produced here. Okay, so that is for the simple process. Okay, easy of the removal, delicate parts require easy removal of the maskant. Okay, means whatever the parts we are using, okay, at the end of the material removed, means once the operation is completed, it's very easy to remove the maskant material from the workpiece surface. Okay, like as I said that how we are wrapping it. Okay, or if we are like painting it, then we are just keeping the hammer, means when it will completely dry, after that we are applying the hammer on that, so that will basically vanished out. Okay, next is the etchant. These are all about the masking. Second is the etchants. Etchant is what are the properties we have to keep in mind, that surface finish. some agents causes surface oxides which is detrimental to the surface finish. So we have to keep in mind that like NaCl and the hydrochloric acid like HCl, there is no oxide is there, but when we will mix it with the water, obviously we have to mix it, so that time that will produce the oxides, okay. But these agents produce the oxide quantities very less, but some are like they are producing the oxide in very high quantity, so we have to keep in mind that will damage the workpiece, okay. And because of that the surface finish will be very poor, so we have to keep in mind these things. Removal rate, active agents remove material faster, reducing the machining time. The meaning is, if we are using the strong agents, okay, so that will react with the workpiece very fast, and that will save our timing, means machining timing, okay. Last is the material type. The selection of agent should be like that prevent intergranular cracking. Means when we are selecting, if we are saying that we are using this NaCl for the steel part and HCl for the aluminum part, that time we have to keep in mind what are the things. That is, first is the intergranular cracking should not be there, hydrogen embrittlement should not be there, or stress corrosion cracking should not be there. Corrosion, there may be a full chances the removal of the material by the chemical is there will be a corrosion only, but there should not be cracking. Stress corrosion cracking should not be there. Hydrogen and embrittlement means there should be no absorbment of the hydrogen particles, okay. There should not be absorption of the hydrogen in the steel, okay. And there should not be intergranular takes, okay. That as I said that crack is initiated and flow make, then this material chemical solution will fall inside that, okay, so that will cracks that. So we have to keep in mind. Now there is only one possibility that as I said that if you are keeping a small hole, okay, whether it's on mask, that will create a problem means the chemical solution which causes the liquid, so that will enter inside that, and that will means because of that your complete part, this assembly part, that is completely gone, okay. So we have to keep in mind that and there is only one disadvantage, that is undercut, okay. That is only the disadvantage. So what is this undercut is, during the etching material removed from the unexposed surfaces or from inside the masking, this etch distance inside the masking is termed as undercut. What the meaning is, I am explaining that मान लीजिए कि this is your workpiece, okay, and over that you are applying the mask, okay. Now first, as I said that if there is a 0.025 mm of the removal of the material in 5 minutes, if we are using the particular agent, okay. So what we are doing is, if this is liquid is spilled outside this one, so point, because this complete surface is in contact with this chemical solution, okay, so this will remove material throughout this, whatever the area that is in contact. So for an example, if it is 0.025, then this will remove the material from this area, okay. Now this area is clean, it means what is happened over here means, now if this is removed, then definitely means like after 5 minutes what we are doing is, we are bringing it outside, we are shaking this one, and again we are keeping it. So what will happen if we are again we are bringing it outside and shaking means this much amount of the material will be removed because of the shaking, because that is already come into the like mixture of slurry, okay. It's kind of material plus chemical solution is there, so it's a slurry. So when you will shake it, once dry it complete, then it will automatically remove from that area. So but what will happen over here, this area is now ready to expose to the chemical solution. So what you have to do, you have to apply the mask over here, whatever the surface is this, like 0.025. So what you have to do, this 0.025 distance, okay, for this you have to apply the mask, okay. Now similarly in this side also you have to apply the mask. For an example, if you have to make final shape will be like this, then what you have to do, first you have removed the material of 0.025. Now again, once this material is removed, you will dip it inside. Means now here the mask is done. Here, when this much amount of the material will remove, okay, when this much amount of the material will remove, now this surface will come in. Now this surface is exposed to the chemical solution, so there may be a chances that whatever the mask you are applying over here, and similarly when you will apply the mask over here, it should not be proper, or while machining itself, chemical machining itself, the material is removed from this area, so there may be a chance that chemical solution can be move inside. Okay, so when it will move inside, so that will basically initiate that will remove the material from this area as well. So what you have to do, that will create the undercut, that is only the undercut. Okay, so what you have to do, if like this is this workpiece initially length of 100 mm. Okay, this is of 100 mm, and now this is like 70 mm, you have to make it final. So this 30 mm you have to make it final, and 70 mm you have to remove the material. Okay, so what if you have to remove, if you have to remove 70 mm and final there will be 30, then please try to maintain, initially take this masking at some more length, okay, like 35 or 40 mm. So whatever the undercut will be there, okay, that will be in the range of 30 to 40, 31 to 40 only. Okay, so after once completing this one, if we are keeping this 40 mm, okay, if you are keep, this is 30, okay, and this is complete 40. So if this will be looks like this one, okay, see तरह का दिखेगा आपको. Now the mask is also removed from this area. So what you can do is you can apply the mask over here, and in the container you can keep this one like this. Okay, this is like this. Okay, so whatever. Okay, so this is mask. Okay, and up to now this is 30, this is 30, and this is whatever 10 mm was there. Okay, so just now here this is the chemical solution, so just dip it inside, so that will remove the material from this area. Okay, so through this basically we can perform the operation. So this is a chemical machining operation. Fine. There is a okay. So there is a two formula, that is H factor, because as I said that we are studying from the gate perspective. So we have to keep in mind that whenever there is a formula, we will discuss it. Okay. So first is the H factor. So H factor is defined as that how much undercut is there and what is the depth of cut we are maintaining. Okay, means what is the depth of cut, like initially if we are taking this depth of cut is 0.0 25 mm, okay, for 5 minutes of the removal of the material, and during this part how much undercut is there, so that we have to keep in mind, first thing. Second is अगर मान लीजिए ऐसा ना करके, if they are saying like for the 5 mm of the material, like 5 mm आपको इस साइड में रिमूव करना है, तो 5 mm आप एक साथ तो रिमूव नहीं कर सकते, you have to go by step 0.25, then again 0.25, then again 0.25, it's like that. So you have to keep in mind that 5 mm के लिए how much time you are removing the material, and if 0.025 mm के लिए, if we are saying that 0.001 mm is the undercut, then please keep in mind that for 5 mm how much undercut will be there. So from that you can calculate this etching factor. Okay, similarly there is a rate of etching is there, that how much depth of cut we have to remove, that this is 0.025 mm per 5 minutes, because it depends on the agent. Okay, so from that basically we can calculate the value. Okay, so that will be the rate of etching. Fine. Now last slide is that is about the masking method and the application part. Masking method is there are three types of the masking method is applicable. Like it's a simple, like in the pandemic time we are applying the mask. So first we have to keep mask, first we have to hang it from this side and we keep, and then again hang it from this side and like this one. Okay, it's like from both the sides. So these are the three options. Similarly in the chemical machining also we have a three masking operations. Okay, so method basically first is cut and peel. The meaning is, what is this, is like this is the work piece. Okay, and what for that, in the cut peel basically we are using the rubber. Okay, so this is the work piece, over that the rubber coating is done, complete coating. Okay, so complete coating is done, and what we have to do is we have to remove the material, means we have to make a hole over here. Okay, a drill, we can say. Drill means a complete hole throughout the thickness. This is the thickness. So this complete thickness we are removing the material. Fine. So what we can do is we have coated with the rubber. Now a simple scissor and all these things, we are removing the material from this area. Okay, so we are removing the material from this area and this area as well. Now the material has, this rubber has been removed. Now this surface is exposed to the chemical solution. So a chemical solution will come in contact with this area, and that will remove some, like for 5 mm we are 5 minutes we are keeping, and that will remove some specific amount of the thickness. So that will remove the material from here and from here as well. Now we'll keep it outside and shake it. Okay, once it dries, once it will dry, and again the material, now this material is removed. Now again we are keep dipping it inside the, sorry, again we are dipping it inside the material. Okay, so for that, now this much amount of the material is removed. Now this much amount of the material is removed, and this much is removed. Now again we will, when we'll keep it in the material, now this surface will expose to the chemical solution, so that will cover some area. Okay, so next it will be like that, and like this we can remove the material. Okay, so this is basically a drilling operation. Okay, now next is the screen printing. Screen printing means whatever the mask that you are using. Okay, this is very simple, that if this is the workpiece, and whatever the mask of specific material we are using, just print it accordingly, that whatever the shape you needed over the surface. Okay, whatever the surface means, for an example, this is the kind of random surface, this is a random surface which you want to shape over here at some depth. Okay, so what you can do is you can make the mask of this material and just print it accordingly. Okay, just give the shape to the sheet, okay, the mask sheet, and print it, and then you place it wherever you this surface is want to you. Okay, so if this surface is mount here, then from the top view it will be visible like this. Okay, so that will just put it into the chemical solution. This surface will be exposed to the chemical solution, so that will remove the material, and jitni bhi thickness tak aapko material remove karna hai, you can go for it. Okay, third one is the photo resistance material. The meaning is because it is a masking method, that's why the chemical removal of the material will be same. These are just a masking method कि masking किस तरह से की जा सकती है. ठीक है, so in the mask photoresistive mask, this photosensitive material we are putting over there on the workpiece. This is the workpiece. Okay, this is the workpiece, and we are keeping this photosensitive material. So what we are doing is whatever the shape that is you needed. Okay, the specific shape, ultrasonic lights we are using, sorry, ultrasonic lights we are using. Okay, UV lights, and whatever the shape that you require. If for example, if this top view, if this is the front view, and if the top view of this one is like this, then just pass, if you want this kind of shape over here over the top, then pass these ultra violet lights like this. Okay, so what will happen, this area, the initially जो screen printing में आपका print होके आ रहा था ये area, because here is a material, masking material, but inside there is no material. Okay, तो ये वाला जो print होके area आ रहा था, यहाँ पे आपको printing की जरूरत नहीं है. Once you can keep this photoresistive material over the workpiece surface, whatever the shape is required, just use the ultraviolet lights accordingly, so that will remove the material from the photo masking. Okay, so once this shape is formed, now this area is exposed to the chemical solution. So again it will be the same process. Okay, so these are the three methods for the masking. Application part is removal of the large amount of the unwanted material from the surface to reduce the weight. Okay, now because of this removal of to reduce the weight only, we are increasing the stiffness to the weight ratio. And is you know that in aeroplane, sorry, in aircrafts, like the body is very large. Okay, large body, large part is there. So if we have to remove the material, then it's very difficult, because that is not a process layout, that is basically a product layout assembly. Okay, so for that we have to keep all the machines there only. So we have to keep all the machines, and we are removing the material there itself. Okay, so machining, by doing applying the conventional machining, if we have to remove the material, if we have to reduce the weight, then we cannot apply conventional machining there, because that will become a complex. Okay, so what we can do is we are applying this chemical machining if a small amount of the material is required to reduce the weight. Okay, or if there is any complex geometry that is formed over there and we have to remove it, for that also we can use this chemical machining. Okay, so this is the simple application. So thank you so much, guys. In the next class we'll discuss the electrochemical machining. Thank you so much.